Hello. In this video, we're going to go through a few remaining problems from Unit 5 on trigonometry. Now let's take a look at this first one. Determine the measure of the angle in standard position given the coordinate point on the terminal arm as -3, -6. Answer in degrees. And again, as we're working through these problems, feel free to pause the video and try them on your own, and then go ahead and watch my solution. Okay, so we want to draw a quick diagram here. The point is at -3 and -6. And so we have the point right over here. It says that's the coordinate point on the terminal arm. So we can draw our terminal arm like that at -3, -6. And now we're asked to find the measure of the angle in standard position. So that means we need this angle right here. Now to find that angle, it's really helpful to draw a little triangle. If we draw a little triangle here, we'll see it's got one side with a -6, another side with -3. And what we can do is put a little theta inside there, a little reference angle, if you will. So when we're solving for that reference angle, we notice we have opposite and we have adjacent. So we can use tan of theta equals, well, -6 over -3. So that's going to be theta equals tan inverse -6 over -3. So if we go ahead and grab our calculator, making sure we're set to degrees, and we do tan inverse of -6 over -3, we're going to get theta equals 63.435 degrees. Now, if you look at our diagram, obviously theta isn't 63 because theta is in quadrant number 3. It should be more than 180. Remember, this over here is going to be 180 and this is 270. So clearly theta, at least the theta we got from our calculator, isn't quite right. So we have to adjust it. What we found when we did our tan inverse was we actually found just the reference angle, that small angle in the little triangle. To find the whole angle, the angle from the origin over here all the way around, we have to actually add 180. So theta is going to be equal to 63.435 degrees plus 180. In some ways, what we have here is theta r. We have the reference angle from the little triangle, not the overall theta. And how do we know to add 180? We can just look at the diagram and figure out kind of roughly what quadrant it's supposed to be or what angle we're supposed to add. And we get 243.435 degrees. Now we'll go ahead and jump back to a few calculator, no calculator questions, just to kind of overall review from the unit. So let's look at something like this, 6.943, convert it into radians. Well, whenever we're going from degrees to radians, we have to multiply and divide by something. The answer is we have to multiply by pi and divide by 180 degrees. Just so you know, if you're going to go the other way, of course, we have to multiply by 180 and divide by pi. But let's do our example here. We're going from degrees to radians. So we take 6.943 degrees, multiply by pi, and divide by 180. Now, because there's so many decimals here, this is definitely a calculator question. So you go ahead on your calculator, you multiply by pi, you divide by 180, and you get 0.121. Now, it's nice to write rad next to it just so we know that it is a radian. And again, if you're wondering, we want 3 decimal places. We want to make sure that we have a nice rounded final answer. Let's go ahead and go the other way. Let's convert rad into degrees. So here, if we want to go from radians to degrees, we multiply by the opposite. We multiply by 180 and divide by pi. So you go 9 pi over 7, multiply by 180 and divide by pi. Again, you can just type this all in your calculator because it is a calculator question. If you're noticing, the pi should cancel. And so you're actually going to get a nice fraction. You're going to have 1620 over 7. But it's nice to put it as a decimal because it's a calculator style question. So we do want to write it as 231.429. And make sure you put that little degree symbol. All right, let's try a principal angle question. How do we find the principal angle of a really large angle? 49,136 is pretty big. We're going to have to subtract groups of 360. but how many 360s do we have to subtract? And to figure out how many 360s, what we're going to do is take our approach that we normally would do with this type of question and use long division. So we take 4, 9, 1, 3, 6, and we divide it by 360. And that's going to give us 136.48 ... And so what we do is we pop back and we go ahead and grab the important part of that. We grab the 136. And then we just continue on. So we have 136 groups of 360. That's how much we have to subtract off. So 360 times 136 is going to be 48960. That's how much we have to subtract from the 49,136. So we go 49136, subtract 48960, and that's going to give us 176 degrees. And that is our principal angle. If 3 and negative 5 is a terminal point on the angle, determine the principal angle. Again, we want to draw a diagram for this kind of question. And so we go at 3 and negative 5. 3, negative 5. And we're looking for the principal angle. In other words, we're looking for this angle right here. So this is similar to a question we did earlier. We need to figure out what the angle is, and then we need to use our inverse trig functions. So let's go ahead and draw the little diagram. We've got a 3, we've got a negative 5. So we're going to have, if we put our little theta in here, we're going to have tan of theta equals negative 5 over 3. So then you get theta equals tan inverse of negative 5 over 3. So theta equals, let's go ahead and type that in. Looks like I'm getting negative 59.036. Now that's a bit of an awkward answer. A negative number, and I'm supposed to be in quadrant 4. So you have to sort of work with this, because this is, again, theta r. This isn't the principal angle. Remember, a principal angle should be between 0 and 360. So obviously our answer is wrong right now because it's negative. And you can tell it's in quadrant 4. It should be somewhere between 270 and 360 just visually. So we have to work on it a little bit. And usually what I do is right away I just go ahead and I drop the negative sign. I just take that negative sign and I just drop it, because what the 59 is representing, sure, it's kind of going backwards, but we need the overall number of 59. And that's what the triangle angle represents. This thing in here, this thing is 59, not negative 59. And then I think to myself, well, how would that overall angle look? How would that overall angle, it looks like it's a little bit bigger than 270. It's almost like we went all the way to 360 and then we went back by 59 degrees. So I would take 360 and I would minus 59.036 degrees, giving me a final answer of 300.964 degrees. That would be my principal angle. All right, let's go ahead and switch gears and try some no calculator style questions in the same flavor, but these are going to be questions where you have to convert or determine values without a calculator. So let's take a look at this first one. Convert 405 degrees into radians. So again, we have to take our 405, multiply by pi, and divide by 180. But in this situation, we don't have access to a calculator. So we can write it as 405 pi over 180. And I guess technically that is right. But it's nice to simplify. If you notice, they both are divisible by 5. We have 180 is divisible by 5, and 405 is divisible by 5. So if we divide by 5 on the top and bottom, we're going to get an 81 on the top. And then when we divide 180 by 5, we're going to get a 36. Now looking at these, I think they're both divisible by 3 as well. 81 is going to be 27 times 3, using a little mental math. And so I can divide by 3 there. 36 is going to be divisible by 3. That's just going to be 12. Now it looks like again we can do another division here. Looks like another divide by 3 and another divide by 3. So that's going to give me 9 pi over 4. And that number just looks a lot nicer. It looks a lot cleaner. Is the other one right? Well, I guess technically sure, but it's always nice to simplify your fractions. How about 17 pi over 6 converted into degrees? Well, you take the 17 pi over 6, you multiply by 180, and you divide by pi. Now again, we want to cancel those pi's right away because we don't want to carry those any longer than we have to. And the 6 can actually simplify with the 180 because 6 goes into 180 an even number of times. So you can reduce it to just a 30. So that's going to give you 17 times 30. Now we could do 17 times 3 as 51, and then add the 0, so 510. Put the degree symbol and box your answer. If your mental math is a little bit weak, you could always do the 17 times 30 on the side, and then you're going to get the same number of 510. Let's determine the value of cotan of negative 3 pi over 4. Now some of you might think, oh, 3 pi over 4, that's like a unit circle value. And while it is, the negative is kind of messing us up. We need to add 2 pi so it's a nice principal angle. It's something between 0 and 2 pi so we can recognize it on the unit circle. So we need a little fraction work here. We're going to add 2 pi. But to do that, we're going to actually have to add 8 pi over 4. And so that's going to give us 5 pi over 4. So what is cotan of 5 pi over 4? That's going to be 1 over tan of 5 pi over 4, because cotan is 1 over tan. Or if you want to think about it, it's going to be cos over sine, both of them at 5 pi over 4. Now, if you have your unit circle handy, that's really good. If not, you can always do a little rough sketch. So here we're going to have 5 pi over 4. It's a little more than pi. It's going to be down here. And at 5 pi over 4, the coordinate is negative root 2 over 2, negative root 2 over 2. So that's going to give us cos equal to negative root 2 over 2. Sine equal to negative 2 over root 2, which are both the same number, so they cancel out, leaving you with just a positive 1. How about a sketch? We might have to do a sketching question without a calculator. And to do that, we need to know the original table, or the original kind of base graph for x and cos x. Note it could be theta, it could be x. We can use really any letter we want here. So x, let's go ahead and graph it. Let's go ahead and graph it in radians just for fun here. So our angles are going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And cos is the one that goes 1, 0, negative 1, 0, and 1. Now we have to do the transformations. This 2 and this negative 2 are both going to affect the y values. We're going to multiply them by 2 and then subtract 2. That's going to give us, well, we're going to have the same x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. But the y values, 1 times 2 is 2, minus 2 is 0, then negative 2, negative 4, 0, negative 2, and 0. So you go ahead and draw a little xy axis. You plot your points here, 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 and here. Making sure to label everything as pi over 2, pi, 3 pi over 2, 2 pi, negative 2, negative 4. And then you connect your dots with that nice, beautiful cos graph. And you can put some arrows on the end of both. All right, the point negative 2, 3 is located on the terminal arm of theta in standard position. Determine sine and cotan. Well, again, let's draw a quick diagram. Negative 2 and positive 3 will be up here. Negative 2, positive 3. And we can draw our little diagram with the sides of the triangle being 3 and negative 2. We're looking for theta. Well, we're actually looking for sine theta. And if we remember, based on SOHCAHTOA, sine theta is going to be opposite over hypotenuse. Here, this is going to be the opposite side, but this is the hypotenuse. It's missing. So we have to do a little bit of Pythagoras on the side. Negative 2 squared plus 3 squared equals c squared. 4 plus 9 equals c squared. 13 equals c squared, and so c equals square root 13. Remember, the hypotenuse is never plus minus. It's always just positive by convention. So sine is going to give us 3 over root 13. Or if we rationalize, 3 root 13 over 13. And we can check with the cast rule, C-A-S-T. Sine should be positive, which it is. So that's great news. Cotan theta is going to be, well, it's the opposite of tan. And so if tan is opposite over adjacent, then it's going to be adjacent over opposite. Adjacent is negative 2. Opposite is 3. And we're good. Again, we don't need our calculator because we're not finding theta. We're just finding sine of theta. So we're finding the ratio, not the actual angle. If we needed the angle, of course, we would definitely need a calculator. How about this question here? Could we determine if this point is on the unit circle? Well, again, we're in the no calculator section, but the unit circle equation says that x squared plus y squared has to equal 1. So we can take our x and square it. We can take our y and square it. And then we can see what happens. Well, that's going to give us 36 over 49. It's going to give us 13 over 49. And that's going to give us 49 over 49, which is 1. So yes, it is on the unit circle. All right, hopefully you enjoyed these questions. Again, this is the end of Unit 5, but we are going to be coming back in Unit 6 for some more trigonometry. So stay tuned as we do some more advanced graphing and as we solve some trig equations. As always, thanks for watching.